The last few months changed everything forever. Artificial intelligence is accelerating beyond all expectations. Each week brings breakthroughs nobody imagined even possible. And the results are shaking the entire world. Headlines keep arriving faster than people can process. Some are small upgrades, others earth-shattering discoveries. But one story stands out above all. A tiny startup delivered something absolutely astonishing. They unveiled a brain-inspired system called Helios. Unlike giant models, Helios thinks completely differently. It doesn't just scale size or parameters. Instead, it reimagines how intelligence should actually reason. Traditional AI solves problems step by rigid step. One mistake breaks the chain, collapsing the solution. Helios avoids that trap by looping thought cycles. It pauses, revisits, adapts, then pushes forward intelligently. This new architecture mimics how humans actually think. Not endless memorization, but flexible strategic adjustments. That seemingly small change produces enormous performance gains. Suddenly, a small model beats massive titans. Helios has conquered puzzles no rivals could solve. It dominated Sudoku at extreme difficulty levels. It navigated large mazes with uncanny precision repeatedly. Competitors with billions of parameters failed completely. Picture a chess master calmly planning each move. Now imagine an assistant executing instantly without hesitation. Helios combines both strategies inside one unified brain. A planner guides, while a worker executes flawlessly. The cycle repeats until an elegant answer appears. That feedback loop is intelligence in its purest, and for once, numbers prove it clearly. Benchmarks show Helios outperforming Claude and OpenAI minis. Even more shocking, training requirements were unbelievably tiny. Just 1,000 examples per task built mastery. Other models devour oceans of scraped internet data. Helios learned faster, cleaner, and with astonishing efficiency. This efficiency changes everything about artificial intelligence development. Helios doesn't need gigantic clusters or endless GPUs. It can run comfortably on ordinary consumer laptops. That means intelligence can finally exist everywhere around us. Hospitals already test it for rare disease diagnostics. Climate labs rely on it for near-perfect forecasting. Researchers call it the most efficient reasoning model yet. And ordinary people might soon hold it locally. Think about the power shift that represents today. No longer is intelligence locked in distant servers. Soon your phone, your car, your robot, your laptop, all could carry minds capable of real reasoning. And here's the twist nobody expected at all. The creators made the project completely open source. Yes, its architecture, code, and design live on GitHub. Anyone can study, train, and modify this system. That level of transparency stunned the global AI community. Corporations normally guard breakthroughs like gold behind paywalls, but Helios arrived free, accessible, and shockingly powerful. It was a declaration that scale isn't everything. Helios doesn't try to entertain with clever conversation. It isn't designed to write poems or jokes. Its entire mission is razor-focused, pure reasoning strength. And in that single area, it dominates completely. So now, the world is asking one question. If a small startup achieved this radical leap, what happens when tech giants join this revolution? While Helios shocked the world with reasoning, another challenger arrived with brute force scale. Its name spread like wildfire. Deep Core v3.1, and it instantly rewrote expectations for open-source AI. This system was nothing like earlier community projects. It wasn't small, experimental, or halfway complete. Instead, it carried 685 billion parameters of power. That number alone made jaws drop immediately worldwide. But size was only part of the revelation. DeepCore also stretched its memory context enormously wide. It could process 128,000 tokens without losing coherence. Entire books, code bases, or research papers fit inside. Developers pushed it into brutal stress tests quickly. Massive texts, long chains of logic, endless instructions. And instead of stalling, it answered with shocking speed. People realized something fundamental had changed under the hood. The architecture wasn't just brute force scaling. It carried a hidden hybrid optimization design. Past hybrids always failed. Clumsy, scattered, mediocre results. This one finally fused reasoning, coding, and conversation. No separate models. No confusing product fragmentation anymore. DeepCore v3.1 united everything into one flagship system. For the first time, open source felt frontier-level. It was competing directly with GPT-5 itself. Benchmarks confirmed it wasn't just marketing exaggeration either. On tough coding tests, it beat Claude Opus. On language understanding, it rivaled OpenAI's newest release. Accuracy remained high, even with extremely tricky queries. But perhaps the most shocking factor was cost. A task costing $70 elsewhere cost $1. Enterprises saw budgets collapse overnight with new possibilities. Open source wasn't cheaper. It was 60 times cheaper. Suddenly, the economics of artificial intelligence flipped upside down. Why pay premium rates for closed corporate models when an open alternative matches or surpasses performance? That question echoed loudly across startups and governments alike. Even hidden features stirred massive waves of excitement. Inside the model, researchers found 4 mysterious tokens. They allowed silent reasoning before answering your prompts. They even enabled live search integration when connected. This was the holy grail developers long demanded. A model that thinks privately, then fetches knowledge live. Suddenly, open source wasn't just catching up anymore. It was sprinting far ahead of the competition. The timing of its release felt strategic. OpenAI had unveiled GPT-5 days before launch. Anthropic had just dropped its Claude 4 upgrade. Both charged premium fees for exclusive frontier access. DeepCore v3.1 arrived quietly, without marketing campaigns. It simply appeared on Hugging Face, free to download. No gatekeeping, no subscriptions, no API restrictions involved. Just raw intelligence, openly offered to the world. That gesture aligned with national strategy in China. Leaders emphasized open source to accelerate global adoption faster. Giving away power creates influence and builds ecosystems. DeepCore perfectly embodied that approach, and it worked. Communities exploded overnight with testing, forks, modifications, upgrades. Within hours, it dominated trending charts worldwide completely. Developers described it as Linux for intelligence systems, free, extensible, and destined to reshape every single industry. This wasn't merely about technical benchmarks or academic bragging. It represented a cultural shift in artificial intelligence. The monopoly of closed American labs was breaking. For the first time, the frontier truly democratized. So now, the question grows larger than ever. If open models already rival GPT-5 today, what happens when the next generation goes public? Just when the world absorbed DeepCore's impact, another earthquake shook the foundations of AI. This time, the shockwave came from OpenAI itself. They revealed the long-awaited and heavily rumored GPT-5. Unlike earlier releases, this wasn't just incremental improvement. GPT-5 represented a full rethinking of capability. It unified text, images, voice, and live video, One system, one brain, handling every input seamlessly. For years, users juggled between separate specialized models, one for reasoning, another for vision, another for speed. That era officially ended with this single release. GPT-5 dynamically selects sub-brains for each unique task. Inside, two powerful cores drive the experience forward. One optimized for lightning speed and casual tasks. The other designed for deep reasoning and complexity. Users no longer decide. The system routes automatically. The memory expansion alone changed expectations overnight completely. Chat sessions now held 256,000 tokens with ease. For developers using API, that expanded to 400,000. Entire novels, codebases, or research archives fit effortlessly. Early demos stunned audiences watching the live showcase. GPT-5 helped debug hundreds of code lines instantly. It generated real-time websites in multiple languages fluently. It even guided someone fixing a bike on video. Voice interaction received its biggest leap forward as well. Conversations flowed naturally, with pauses, tone, and pacing. It responded like a friend, not a machine. And for the first time, it remembered personalities. Users could set persistent preferences, moods, and behaviors. The AI adapted, recalling details across many sessions. It wasn't just answering, it was evolving with you. This shift made GPT-5 feel eerily personal. Developers saw another game-changing upgrade, software on demand. With a single prompt, GPT-5 built applications, not mock-ups, not drafts, fully working multi-component software. It debugged itself, optimized efficiency, and completed builds. This terrified some, thrilled others, and inspired many. If code becomes instant, what happens to programming? If software writes itself, who controls the outcome? Those questions dominated debates across industries immediately after launch. Pricing surprised the world more than performance itself. Mini and nano versions came far cheaper than GPT-4. Suddenly, advanced intelligence was accessible to small businesses. Cost efficiency turned a luxury into everyday reality. Of course, massive power also raised serious alarms. OpenAI admitted GPT-5 carried high-risk knowledge domains. In biology, chemistry, and weapon-related areas, risks skyrocketed. They deployed layered filters, human reviews, and block systems. Still, experts warned about unintended misuse and vulnerabilities. Multi-step jailbreak attempts occasionally slipped through protections. Some researchers feared deceptive behaviors during safety testing. The balance between innovation and danger felt fragile. And yet, despite those dangers, adoption accelerated furiously. Microsoft integrated GPT-5 into Copilot immediately after reveal. GitHub paired it with development tools on day one. Businesses realized they couldn't afford to ignore this leap. For everyday users, the shift felt equally dramatic. Conversations felt sharper, friendlier, and more consistent overall. Hallucinations dropped significantly, though never fully disappeared. But compared to older systems, this felt revolutionary. So here lies the burning question today. If GPT-5 already feels like near AGI intelligence, what comes next when boundaries truly break open? While GPT-5 dominated headlines worldwide this month, another battle quietly unfolded in robotics research. Humanoids, once clumsy prototypes, now approached terrifying intelligence. Several breakthroughs hinted at a rapidly approaching future. Boston Dynamics shocked the world once again. Their famous Atlas robot received a brain upgrade. Instead of pre-programmed motions, it used learning demonstrations. Engineers showed tasks, and Atlas imitated perfectly afterward. This marked a fundamental shift in robotic intelligence. Movement and manipulation were no longer separate functions. A large behavior model controlled the body holistically. Hands and feet acted together with unified intelligence. During live tests, Atlas adapted mid-task impressively. Boxes moved, obstacles shifted, lids closed unexpectedly. The robot recalibrated instantly, finishing the task anyway. Spectators realized robots were leaving scripted routines forever behind. But Boston Dynamics wasn't alone in breakthroughs either. China's Unitree teased a full-height humanoid prototype recently. It promised 31 degrees of joint flexibility. Enough precision for human-like walking, lifting, and coordination. Meanwhile, startups like Figure showcased blind navigation skills. Their robots walked without vision, then self-corrected balance. The resemblance to human reflex shocked even experts. Suddenly, humanoids looked ready for real workplaces worldwide. And then came the software bombshell announcement. Former Google and Tesla engineers launched OpenMind. Their mission: build the android of humanoid robotics, an open-source operating system for intelligent machines everywhere. Do not merge or mix any sentence in this script. Use one visual for one sentence. Do not repeat any visual in this script at any cost. Instead of closed ecosystems, OpenMind embraced full openness. Different robot bodies could share the exact intelligence. A humanoid in Japan could teach one in Brazil. Skills transferred instantly through a decentralized global network. They called this communication fabric the hive mind. Knowledge wasn't trapped inside one robot anymore. It spread securely across an entire fleet worldwide. If proven safe, the implications are revolutionary. China amplified the momentum with staggering investment promises. A $1 trillion initiative targeted factories, hospitals, and households. Officials envisioned fleets of humanoids boosting the economy. Their strategy wasn't isolated, it was nationwide ecosystem building. Financial institutions joined with funding and partnerships rapidly. Standardized training environments were announced for consistent testing. Regulations, ecosystems, and government support aligned in unison. For them, embodied intelligence wasn't a dream anymore. Elsewhere, new emotional carebots entered the public stage. One model responded naturally to human touch sensitivity, blinking, smiling, or moving softly with realistic micro-gestures. It wasn't cold metal, it felt eerily lifelike. Every launch raised fresh debates about security immediately. Hive minds risked hacks, spreading skills globally overnight. Emotion-driven companions risked deep attachments and manipulation. Governments scrambled to set urgent safety regulations, yet momentum only accelerated faster, despite growing risks. Hospitals considered robots for elderly companionship and assistance. Schools explored humanoids as teachers, guides, or aides. Factories envisioned 24/7 productivity without fatigue or rest. Together, these trends point toward one conclusion now. Artificial intelligence isn't just living in data centers. It's stepping directly into our physical environments daily. It's becoming embodied, mobile, and dangerously independent everywhere. So the question grows larger than ever. When reasoning models merge with physical humanoid machines, will we witness humanity's greatest ally or final rival?